All right, so this is still Saxon's Trig lesson 9. It's example 3, which I just forgot to put on the last video. So let's read on page 71, example 3. In the problem, oh wait, that's not the, no. Yes, it is. In this problem, we will remember that if two segments have equal lengths, the halves of the segments have equal lengths. All right, so let me start off with the givens. Segment AG matches with EF. CA, so that's this big line. I might just do my 2 tick marks over there as a reminder. Matches with CE. Okay, so big line, that line, okay. And then B is the midpoint. B is the midpoint of AC. Okay, now midpoint means in the middle. So this is not drawn to scale, but it definitely means that this side and this side are the same length. And then D is the midpoint of CE. So I'm going to mark them with a 4. And it wants me to show BG, this side, matches DF, this side. All right, so I've marked everything that I had given. And so in my statement, I would have listed my givens, and obviously my reason is given. And now let's plan out what we have, and we know where we're headed. So I have in this little triangle a side that matches. Information here, but they're not the same markings, but I think that will help me. And this is the third side, and I know nothing about given angles at this point. However, I do know that this side and this side are the same, so their angles have to be the same rule we used in reverse in the last one. So I feel like that would give me a side, an angle, and a side, and then I would have what I need. Okay, so since I've written my givens out, I did something when I marked the picture that I did not write in my list. So I can accurately mark this one and this one from the given, and I can mark this one and this one from the given, but I labeled using midpoint that these two and these two were the same. So I need to write that as my second step because it was not actually in my given. So why can I say that AB is congruent to CB, and the same in saying CD is congruent to ED? Why did I say that? Because I was told that B and D were midpoints. So that is definition of what a midpoint means. It's in the middle, so it has to have cut those into equal pieces. Now everything that I labeled in my diagram is in my rule, my proof over here. All right, so we said if we've now said these sides are the same, we can say that the angles opposite them are the same. So I can state that angle A is congruent to angle E. Why? Because it's opposite, or angles opposite, equal, or congruent, either way, sides. You get the idea there. There are actual, like in a full proof, you wouldn't use these. You would look up like postulate 1.1, theorem 6.8. We're not getting into any of that. So at this point, even when we do these, it's perfectly okay to just list what the rule was, not force everyone to go into the back of the book to look up what are the theorems, what are the postulates. That's irrelevant. Okay, so moving on with our basics here. All right, so now we have stated the side from here, the angle from here, and then we've said this side and this side. Now we've not said that they are the same. Okay, so if we do that, we have our third piece. Can I say that the side marked 3 and the side marked 4 are the same? Well, these sides were the same length and we cut them both in half. So yes, they have to be the same. So I will say AB is congruent to ED. All right, so then I would basically write that thought process out here, and I would say congruent sides, midpoint segments, are congruent, something like that. Now I have been given all three parts that I need to show. So I can say triangle ABG is congruent to triangle EDF. Trying to be careful that I put them in the right order. Y, side, angle, side. Side, angle, side, written in order. So my final thing is what they wanted me to prove. BG is congruent to DF. C, P, C, T, C. They are part of congruent triangles.